So imagine two scenarios. The first scenario, the teacher walks into the class. Good morning, class. Today you're going to learn how to use the power rule. You're going to learn about derivatives. And the student says, excuse me, why am I learning this? Because you have to. Because it's going to be on the test. That's one scenario. The second scenario. Good morning, class. In 1661, a young lad went to Cambridge and he went to study law because he hadn't done his work, which was going to become the bedrock of a lot of physics later on. But anyways, this young lad named Isaac Newton is studying at Cambridge. But then in 1664 to 1666, there's a plague and he has to go home. One of the things Newton is wrestling with is thinking through astronomy and actually eventually coming up with mathematics to make sense of some of the things he was studying in astronomy and physics and other applications of mathematics. So he co-discovers the calculus. There's a whole story about his relationship with Leibniz, which is another lesson on how to handle conflict for another day. He was a great mathematician and physicist, no questions. But I think that if you introduce it to students in this second scenario, they might lean in a little bit and say, tell me more about this calculus. So now they have a historical backdrop, an explanation of how math and physics connect, and they want to hear the story. That leads me to Calculus for Everyone. Calculus for Everyone, I believe, is a resource that everyone should seek out and learn from because it gives them some context to what they might have learned, in a traditional math class without the applications. See, math is very applicable, right? I'm a medical physicist and we use math for CT scanners. We use math for everything. Math is everywhere. We know that. But the problem is I think too many students are taught math without the context. I believe that Calculus for Everyone can be a great tool even for a student who is not yet ready for the actual rigor of calculus after taking Algebra 2 and Pre-Calc. So how did I come across this book? Well, I was actually working on a project. I've been writing math curriculum tools for about 10 to 15 years, for about 15 years. And I went to a conference in 2025, the ACCS, Association of Classical Christian Schools, and I was just visiting the book tables, right? And I'm working on a curriculum that brings math and math history and everything. And then I stumble upon the Roman Roads table, and they had this book. I was like, man, I was trying to write something like that. But, here's the good news. My version is only up to the end of Pre-Calc. So we still need that, right? And so I just want to encourage everyone to stay alert about what's coming out of the Roman Roads math section, because this is an excellent resource. I believe there's more that will come. I look forward to seeing what they produce. But let's talk a little bit about Calculus for Everyone. That's a little bit of how I got to the book. Now let's dive into the book. So all you need is a very strong base in algebra. A very strong base in algebra will help you understand Calculus for Everyone. It's the subtitle is Understanding Physics and the Mathematics of Change. The author is Mitch Stokes. He says to Maurice Klein, who changed my view of mathematics and my view of the mathematics of change. Maurice Klein has written some very interesting books. Mathematics in Western culture, I believe, is one of them. Something about the loss of uncertainty is another one. So I encourage you to check out Maurice Klein, Dr. William Dunham as well, Paul Lockhart, A Mathematician's Lament, William Dunham's Journey Through Genius, David Berlinski's A Tour of the Calculus, David Berlinski's Newton's Gift. Those are some great resources I think that can help in any math class. They should be in the corner in every math class. Our students should be reading the history of mathematics as they learn the mathematics. Okay, so how to use the book. The book has about 16 chapters. I apologize. It has about 25 chapters. I was thinking of the semester length, 16 weeks, or different number of chapters in a different book. Sorry about that. But so it's if you think of a semester, you could try and squeeze it in that semester. But let's say you're a homeschool family, you could probably take this over the course of a year. I want to give a quick caveat. I think that every child in every nation should take calculus. Every child in every nation. Why? Because it's beautiful. Isaac Newton gave us the calculus and he didn't even have the internet. He didn't have Google. If Newton and his people could do calculus in the 1600s and 1700s, we can do calculus. So I really want us to just keep that, like, I'm pleading with parents, like I'm begging. It's too beautiful not to give it to your child. Don't allow the textbooks that you might have tried to hinder you from pressing on. Calculus is a key. Because think about the history of science. You get to about 1700, and there's this spike. History of mathematics. Calculus allows you to unlock many doors. Even if you're into computer science and artificial intelligence discussions, the mathematics behind it is calculus. And linear algebra and statistics and probability, data science and differential equations and Fourier transforms for, that's used in CT, but also in computer science, some applications with signal processing. But the point is, like, okay, this is a joke, but I mean it sometimes. I think it should be like illegal. Like everybody, just like before you get your driver's license, could we see your calculus transcript, please? Like, it's too beautiful. It's too relevant. It's too, like, it's like learning all these tools along the way and then you don't do calculus? Oh, man. Like, why? Why? Okay, sorry. I'm using pathos a little bit, right? I'm like pleading. Every school in every nation, every student should do calculus. Why do I say that? Because this book is a great tool, even if you're not in a traditional calculus, pathway. But you should still consider making sure you do your algebra 2, your pre-calculus, your geometry. Still do all of the backbone. Let's get back into calculus. Okay, so the problem of change, that's a big topic. That's where the book starts off with. It talks about Pythagoras, then we get into some Plato. There's a few other Greek mathematicians like the Tales of Miletus, Eratosthenes, Euclid. These are other people that our students should study as well. The book talks about space, time, and numbers. Zeno's paradox is a big topic, even in traditional calculus classrooms. It talks about the Platonic and Pythagorean project before the scientific revolution. The scientific revolution is a fascinating topic from about 1476 to 1776. That's what I cover. I cover that in my third book in my series, which is focused on Algebra 2 concepts and that time period. The scientific revolution is fascinating. The printing press kind of gave the stage for some of these things. And then you get Copernicus and you get Galileo, you get Kepler. The world was ready for something. It's like boiling. It's boiling. And then on Christmas Day of 1642, which is the year that Galileo died, this guy is born, Isaac Newton, right? Boom, the scientific revolution. Well, it's not just him, but I'm just saying he's born into this time where, something's about to happen. And Newton happens to come along and he gives us a key. You add Newton into the equation. Euler is born in 1707. Euler is the best. If you disagree, tell me why in the comment section, but I think Euler is the best. Gauss comes in 1777. Gauss studies Euler. Gauss studies the other people. But anyway, sorry, you can see how it's all connected. So Newton and the calculus. Leibniz is key, as we discussed. Bernoulli. The Bernoulli dynasties, they owned the math paradigm. Almost like the monopoly for a little bit. One of them taught Euler. One of them was Euler's classmate. Daniel was Euler's classmate. Math history is fascinating. And I know I've rambled a little bit. But let me finish with the remaining sections. So they talk about limits. They talk about instantaneous speed. The derivative, finding more derivatives. Using the power rule to find derivatives. Graphs and slopes. Slopes and derivatives. Slopes and the problem of change. These are all critical, and then the fundamental theorem of calculus. This book is a great resource for every family to get a better understanding of the nature of mathematics, how mathematics works. Morris Klein says, the calculus has proved to be the richest lode that mathematicians have ever struck. This, I think, could really help students change their mindset in mathematics, and then we give them more mathematics. Because at the end of the day, for me, I want to see students do Calculus 1. Calculus 2, they might have to do that with some friends. It's going to take some effort for a lot of people. Calculus 2 was not easy when I took it. But I still think it's beautiful. And then they should do Calculus 3 and beyond. So thanks for watching. Check out Calculus for Everyone. That's a little bit of my story as it ties to how I found the book. Take care and have a blessed day.